Okay, today I'm going to talk to you about halogen reaction. There's three different types of reaction that we need to know involving halogens. Okay, so just to recap, halogens are in group 7 of the periodic table. So fluorine, chlorine, bromine, iodine and astatine. And they undergo some reactions that we're going to look at now. So the first type of reaction that we need to know about is their reaction with metals. So I'm going to show you a nice simple example. It's a really simple reaction. So they basically, halogens will react vigorously with some metals to produce salts called metal halides. So here's an example here. Sodium plus chlorine makes sodium chloride. Okay, so just to show you the symbol equation underneath, the metal is all by itself. Chlorine, here is our halogen, chlorine, and we're forming sodium chloride. Now just to balance it, I need to do this. Now, it's a really simple reaction, but we need to know about this substance which is formed here. This is called a metal halide. So it's a really simple reaction between a metal and a halogen to make a metal halide, sodium chloride, for example. If we react with a different halogen, for example, fluorine, we'd make sodium fluoride instead. Notice that when the halogen's all by itself, it ends in INE, and when it's in a compound, it ends IDE. The next type of reaction that we need to know about are reactions between a halogen and hydrogen. So hydrogen is just a gas. So again, I'm just going to show you the really simple equation again. Again, this is really straightforward. Hydrogen plus chlorine. So again, here's my halogen here, and I make hydrogen. Now this is chlorine when it's by itself, but it's in the compound, it's chloride. Hydrogen chloride. So just to show you the how this looks underneath, hydrogen is H2, chlorine is Cl2, and hydrogen chloride is HCl. Just need to put a 2 in front to balance it. So what we need to know about this compound, our hydrogen chloride, is the fact that these are called hydrogen halides. So look, it's very similar to having, when we react a halogen with a metal, we make a metal halide. When we react hydrogen with a halogen, we get a hydrogen halide. Now these hydrogen halides actually dissolve in water to make acidic solutions. For example, 2HCl, this would dissolve in water to form hydrochloric acid, which is a strong acid. So as you can see, those first two types of reactions are very simple. The next type of reaction that halogens we need to know about involving halogens are displacement reactions. Now all a displacement reaction is when a more reactive element replaces a less reactive element. So we're going to have a look at this example here. Here we have chlorine all by itself, and we have potassium bromide. So potassium and bromine in a compound here. Now, if we have a look at our halogens, as you go, basically at the top you have your most reactive elements, and the further you go down your group, you get less and less reactive. So if we look at the two different halogens here, chlorine and bromine, we can see that chlorine is more reactive than bromine. So because chlorine started by itself, it will be able to replace this bromine. Because it's more reactive, it replaces it. So instead of now having potassium bromide, I would now have potassium chloride. Again, look how it ends ide. Now it's in a compound. But that's not all. The bromine has now been replaced. It's been kicked out. So now I just have the bromine all by itself. So to quickly show you, this is a symbol equation underneath. It would look like this. KCl plus Br2. And just to balance it, I need a 2 there and a 2 there. So remember, a displacement reaction is when a more reactive element replaces a less reactive element. And we could actually see this. We can actually show the reactivity of the halogens by doing a series of reactions. So what we have here is potassium chloride solution, which is a colourless solution, potassium bromide solution, which is a colourless solution, and potassium iodide solution. What each box represents is a reaction between one of these things and one of these solutions. So remember, if we've got a displacement reaction, we must have a more reactive element replacing a less reactive element. So let's go through and have a look if we'd see any reactions. So first of all, chlorine and chlorine. So the halogen here is chlorine, the halogen here is chlorine. One isn't more reactive than the other. They're the same level of reactivity, so we would not see a reaction here. This time we've got chlorine water and the halogen is bromine. So the chlorine would displace the bromine. And we'd see a change in colour because bromine water is a kind of orangey colour. This one here, if we reacted chlorine water with potassium iodide, the chlorine is more reactive than the iodine. It's higher in group 7. So it would displace the iodine. And we'd actually get a brown solution because iodine water is brown. So let's have a look at this one. If we reacted bromine water with potassium chloride, we could see that bromine is less reactive than chlorine. So it would not be able to displace it. Bromine and bromine have the same level of reactivity, so we would not see a displacement reaction. But bromine is more reactive than iodine, so the bromine would replace the iodine, and the iodine would be left in the water to give a brown colour. Now finally, if I added iodine to any of these solutions, iodine isn't more reactive than chlorine, bromine or iodine, so none of this bottom row I would see a reaction. So those are the 3 different types of reactions involving halogens. Thank you.